Oh, me too. It's kind of cool shape. It's different. Just like you. What was that supposed to be?
Alright, so we get ready into this so that you guys have a lot of time to start your assignment. Your goal today is to use x-intercepts to write equations when the vertex is unknown. So we've been writing equations using a vertex, but you can do that. You can write equations if you don't know the vertex. You just need the x-intercept. So there's another method of writing equations that we're going to practice today. The steps are very similar process. It's the same section of the book. So, all right. So your goal is to look at those graphs on the board and identify the x-intercepts, and then to make a statement about what all x-intercepts have in common. So if you have things to discuss amongst yourselves what the x-intercepts are, you can.
Please, I do know. Please.
That's what's fast.
It's a deep.
Okay, but like.
Huh? That's all. Okay, then I can find it. -6.
That's not even -6, that's -4.
I'm not looking at. I'm looking at Y.
What?
I'm looking at Y, Adrian. Oh. Okay, then I told you -4. No, it's not. Adrian, the second one's a -4, -6. You're closer.
Which one are we looking at? B. Oh, B. Yes.
Oh. Okay, so it's -6. I thought it was a dot. Okay, that should be the dot.
What?
What do all X intercepts have in common?
All right. Before I go over these answers, the homework is on page 85. This is practicing what we did today, and then I gave you a quadratic graph to practice. So for the quadratic graph, you're doing these steps. All right. So that's from last week. You haven't done that in a little while. And then I also put a study tip to like review that soccer problem we did in Bellwork yesterday. There will be a word problem on your quiz tomorrow, so I suggest you just kind of look that one over and understand it. Okay. Any questions on the quiz or the homework? Slash 8, I don't know. It might be more like 8. It won't be like a million, but so it's like 5 ideas, but I'll try to break it down into more questions so that one question isn't worth so much, so like for the graph I might break this down into like this is number 1, number 2, number 3, number 4, number 5, but like honestly graphing is just one question. Do you hear what I'm saying? If I break it down this way, it'll actually help people graph it, like if I ask you specific questions. Okay. I won't, but you can use your notes. With the highest you can get, you can use your notes. With the highest grade you can earn is an 85%. Alright, how'd you guys do? Did you get letter A right? Alright, so it's sometimes we make the mistake of focusing on y-intercepts because in algebra 1, y-intercepts are talked about so much with slope-intercept form. But for algebra 2, we really talk more about x-intercepts. X-intercepts are really valuable. So this is a cubic function. It's a third-degree function. We will graph these later this year. This one only shows one x-intercept at 2. Any questions about identifying x-intercepts? Yes.
It's about math though.
Okay.
Okay. So what did you say?
Cubic.
Okay. So if they're like a specific shape that it embodies, like how a
It's-
quadratic function does, or is it just like
Yeah, it is a shape. So you'll learn that the exponent indicates how many turning points there are. There's always one less turning point than the degree. So x to the third could have look like this. It could even look like that with 2 turning points. X to the fourth can look like that. X to the fifth will look like this. 1, 2, 3. Like that.
those are kind of cool. I like
So we'll spend one chapter in doing this exact thing, talking about odd functions, arrows end differently. Even functions, arrows go the same way, and the number of turns is indicated by the exponent. So yeah, that pattern you recognize is good. Good preview. All right, so number 3, you were to write a statement about what all x-intercepts have in common. Who's got a great statement? Alexander? Alright, this has to become something that you know, you believe, you don't ever forget. It's something that you see y equals 0 and your brain automatically sees x-intercepts. Y equals 0 and x-intercepts, they can be synonyms in your mind kind of forever. Even on the SAT, it would be really helpful at some point. So all x-intercepts have y values that are 0. Does everybody see that in the graph? Y equals 0 in all of those points. Alright, let's check your homework. So I'm going to start by putting up the answers for 3, 6, and 7. So that might not be where your assignment started, that you were supposed to start on 13. But head to 3, 6, and 7 for these answers. Here we go. Here's number 3 and 6. So try to go through each number and say, okay, where did I go wrong? If your answer's not totally right, find your mistake. If you can't, I'll go through. I love finding mistakes. I like to go through that work like a little math detective.
Yeah, because that's what it's doing. Yeah, really. That's okay. What I can't do either. I don't. I chose 9 and 10 because yeah, Fridays were 9 and 10. So yeah. I mean, you guys. Me too. It's so fun. You're right, Retro Friday. I like your shoes. I'm just saying, I like your shoes.
You said you're wearing a red shoe.
No, I didn't. I think you're very red shoe Friday.
What's that?
Oh my gosh. No, it's gonna water everything.
Just drink.
It's just slobber on it. And then you slobber on it. I'm gonna bring you. Actually, no. She doesn't deserve anything from me. Cause she won't come to my house today. I don't care. I'm gonna go over to your house and talk to Leslie and your mom. So and Archie.
Friendship is gone.
Yeah, and Archie. That's what I thought.
I'll go to your house and I drive tomorrow. Yeah, it was actually like
I have a Tesla. Yeah.
and her mom was a Jeep.
Oh, my mom has a Jeep. Oh my god. Anyways, guys, I'm so tired. I'm tired. What time did you go to last night? Guys, what time did you go to last night? What time? 8. It's 7 o'clock. How about you? 9? I went to bed. I already know when she goes to bed. I know her bedtime.
I goes to bed with me.
I go to her house and I sleep with her bed.
What?
I go to her house and I sleep with her bed. Yeah. Oh, they're matching. They're matching. What about shoes? Wow. You didn't even match for shoes.
Bro, I.
Yeah, go.
Yeah, you can leave. We'll replace you with time.
Honestly, Tony's better.
What? That's so
Wait, do you have Tony?
No,
Yeah, last year.
Check number
Yeah.
7.
This Baldwin. This Baldwin. Did you have my brother last year? Yeah. I want to.
I actually did 9 and 10 last year. I don't know why, but I did it. No, it's actually 9 and 10.
Well, let me show you.
Okay.
You know?
Miss, what grade did I get on my homework? Yeah, you did. You were like getting past it. I said there's 7. And then here's 3. Except Miss, on number 7, I accidentally distributed. I want to talk to you about 7, you guys. So you probably, if you did this yourself, have a .33 here. And the problem gives you a decimal, so you're allowed to use decimals for the whole thing. So that's full credit if you did the whole thing with .33. Your numbers here are about 1 decimal different than mine. So this is a cool example about how fractions can be easier than decimals. So when I saw .33 in my calculator, I was like, well, that's 1/3. And I did mine with 1/3, which made distribution come out as more consistent numbers. So I have these nice integers because of the fraction 1/3. But if you had to round your number and cut it off, then your decimals aren't as precise. But it's still right. I'll still give you full credit for your decimals. Who's got decimals in their word? What's it? Does your calculator give you fractions out?
Yeah, because if you, I got .33, but then I just clicked that little button,
So you knew.
so it just said negative 1/3.
You knew the third. Okay. And so here is 13.
Oh, that's a big thing.
I had to draw a picture for 13 and try to figure out what it was asking me, and I very much encourage you for word problems to draw a picture. So, because I didn't know what they meant by how high is the diving board, right? So the diving board is where the person started. So the x value was 0, and we were trying to figure out how high. So after I got my equation, raise your hand if you got negative x squared plus 2x plus 24. Very good. After I got my equation, I had to figure out what information I had to help me with this diving board. And so the x value was 0. So I put a 0 in and got a 24. Or maybe you just knew that was a y-intercept. Caitlin, did you get 24? I do think about it. So you just realized that the height of the diving board was the y-intercept? Did you plug 0? Oh, you don't. Okay. Cool. We got a question on the word problem.
I just took it. Bro, why does that taste like?
I will
I just split it.
almost always get partial credit.
Holy cow.
Is it what? Is it what?
Oh,
I
sick.
yeah, I try. That's why I don't give multiple choice so that you can earn partial credit for whatever you do, right?
Holy cow. Dang it.
All right, let's do some notes on intercept form.
I just need like.
I had you guys write down Annie Bellward last week, I think. I had you write down 3 forms of quadratic functions. It was vertex form, standard form, and intercept form. We've done the other 2. Today is the first time to do intercept form.
Yeah, I got all over. Got any napkins as well? I kind of want to go. Oh. It just feels uncomfortable now. No, I don't.
All right, so you now moving forward have to make a decision. Should I use vertex form or intercept form? So you're gonna have to look at the data you're given. Maybe you're given a graph, maybe you're given a table, maybe you're given a written description. You have to decide. So if I look at this picture, the vertex is not provided. I feel like I know it. It looks like -2.8. But maybe it's 7.9. I don't know. I'm not going to use that if it's not shown to me. So intercept form is for when the vertex is not shown. I'm going to run through all of the same steps, but I'm going to begin with intercept form. So step 1. All right, step 2 is applying P and Q. But what are P and Q, Mrs. Bowman? P and Q are intercepts. That's an x-intercept. And that's an x-intercept. The P and the Q in the model represent x-intercepts. So I'm going to call right here, I'm going to say P equals and Q equals 2. So we don't have HKs here, we have P's and Q's. So I'm at y equals a, x minus negative 6, x minus 2. Yeah, I changed that to x plus 6. You'll notice since there's a subtraction in the form, whenever you plug in a negative, you have to turn it into addition. Yes, and so it's actually like a preference how you want to do it. Like I could FOIL it right now. It's gonna be quicker if you just do the way I show you right now. Step 3, just like before, plug in any other point. So now we're gonna use the other point given the x, y. This is x and this is y, right? I'm going to use that third point given and put it in the xy spot. Negative 4, 6. So now it's 6 equals a. So same step 4. Oh, same step 4, find a. Go ahead and find your a value. Now you need to do the actual math and calculate a.
Yeah, you have to prove it. I don't know. Same thing though. Basically, same thing, right? I got it now. Negative. What the heck? Oh, I didn't find it.
So I'm going to do 2 and negative 6.
Yeah. I don't know if I did it right.